Thank you very much, everybody. Can you hear me all right at the back? Yeah, all good? Everyone got a seat? Just? We are full, aren't we? Okay. So, firstly, thank you for coming to this talk. I know there are a range of other talks going on at the moment, and we now have people on the mezzanine as well. Gosh, a full room. So, thanks for choosing this one. Hopefully you'll find it informative. I'll just warn you now, there's a lot of content in here, so we're going to move a little bit of pace. I know there'll be the lull when the cake that you've all just had sort of settles in about 20 minutes' time. I'll try and slow down a bit then. We'll see how we go. Okay, so stop starting and start finishing. There's a phrase which has been around a long time. I've probably been saying that for about 15 years now. I should say I've been in the Agile-ish industry for over 20 years, so it's been interesting to watch its journey. And I would say the journey for, well, what this talks about, WIP, is even longer, actually. I'm just doing a tiny little bit of a history check here for you folks, because sometimes us Agile people think, oh, this is all new and shiny, and yeah, some of it really isn't. Some names. Winslow Taylor at the top there, an interesting chap. Started trying to apply the scientific method to work. Started working out, actually, how can we make people more efficient, more effective? I know he gets some bad press. I think that's from people who've heard about what he wrote rather than wrote it, but actually he was quite a nice chap. Humanist, wanted people to have better pay, better working conditions, lots of good stuff. Schuhart, interesting chap, written some good books. Schuhart actually was the person who came up with something that you all think was probably invented by Deming. Anyone heard of the plan, do, check, adjust cycle? Or the plan, do, study, act cycle? Yeah, all nodding. Anyone heard it called the Deming cycle before? Yeah, no, Deming would call it the Schuhart cycle. Deming's on this list. But no, Schuhart was doing a whole bunch of experiments in manufacturing process in the 1920s, 1930s. Anyone here heard of the Hawthorne effect? Some nods. Yeah, actually, so this was a result of some studies that he did in the Hawthorne factories to see if you change the light that workers had available to them, whether their work rate would go up or down. And it all produced all manner of weird results. And it looked like people, as the light got less, actually produced more things. The Hawthorne effect is if you give people attention, actually they want to please you and they will work harder. So that was that one. Matsushita, founder of Panasonic amongst a range of other companies, Eastern sort of magnet and thinker in the manufacturing space there. Deming I have mentioned already, done lots of work. Deming's written a lot of books, so some would say one of the founders of modern management thinking, and I would say he was, I won't quite say a student, but almost an understudy for Schuhart back in the 1930s, 1940s. Taiichi Ohno, Toyota production line, the Toyota Way, that's been running since, it's probably got popular in the 1980s. Those folks have spent 40 years trying to improve how they do things. Christopher Hosking, this is somebody in the early 1970s that was based in the UK looking at, worked as a work study engineer looking at performance improvements inside manufacturing in the UK, actually in the food industry. And last but not least, Don Reinertsen. And I don't know how to put a question mark. I don't know how old Don is now, but Don is, I guess, the mathematical thinker behind much of what we know today in the process and flow space. He's written a very seminal work called The Principles of Product Development Flow. Quite a book, 175 different principles on how to think about managing work and workflow. So there's a lot going on here. Now, I've used the word flow a couple of times, and it seems quite trendy. Lots of people talking about flow at the moment. Anyone here getting excited about flow? Flow frameworks, flow metrics, lots of flow things. None of this is actually new. I thought I'd chuck some words up just so we've all got some common reference points here. So now I'm a certain age. I worked in manufacturing back in the 1990s, early 90s. So these are all quite familiar to me. Top of the shop, lead time. And I put some words just to sort of help you think about what they mean. So idea to value, committed to complete, order to fulfillment. Someone orders something, they've got it. That's your lead time. Cycle time, that's when we start doing something to when we finish doing it. Cycle time sits inside lead time, as you'll see. Doing to done, order processing to completion, those kind of things. Throughput, how many things are we producing in a given time period? How fast does a production line run? And there's good old WIP there, work in progress, or some people call it work in process. Actually, I'm pretty agnostic, I like them both. Works for me. And this is somewhere between committed and completed. It's what we've got inside the process at any one time. And then last but not least, I've got process efficiency, which is a simple piece of maths on cycle time divided by lead time. So this tells us, actually, how efficiently we're working. Someone orders something, someone gets it, actually. How efficient is that process? Now, the flow folks, and flow's become quite trendy in the last 2 or 3 years, have come up with a whole bunch of new words for you good people to learn. Now, the good news is they're just the same as the old words. So flow distribution is not on the previous slide. I'd have called it assortment back in manufacturing days. That's just a spread of the different object types inside your process. Flow velocity, that's throughput. Yeah, often averaged by the types above. Flow time, that's lead time. And it can be cycle time depending on when you're measuring it. And there's always a differential agreement or disagreement on that. Flow load is WIP. Woohoo! And flow efficiency is the same as process efficiency. So there's a whole bunch of new words, and they still mean the same things that we used previously. So don't get bogged down in it. Now, I use the word process. What's a process? Anyone out here doing Scrum? All seen Scrum? Yeah, most, nearly all. Good. So this probably looks pretty familiar, hopefully. To do, doing, done. The classic 3-column board that certainly a dozen years ago I would teach people to try and strive towards when doing Scrum, actually, rather than big, long, complicated boards. But actually, inside that doing box are other things. In the classical software space, you might find we're analysing some work, we're designing things, we're coding things, we're testing things, we're integrating. Actually, there's a lot in doing. So doing's a bit of a blunt instrument. And when we start talking about work in progress or work in process, it's better that we have a better understanding of the process we're talking about. And ultimately, you're going to end up with a bunch of things scattered across this that could look a bit like this. And the work in progress is what you can see between to do and done. At least it is for now. At this kind of level, let's assume this is work in progress. Yeah? Feel good? Super. We're not breaking any deep boundaries yet. Don't worry. We'll get there later. So let's assume a little bit of a calendar view here. I've got a 10-day sprint iteration, whatever word you choose to use. We're about halfway through. And let's have a look at what would happen just in a normal team, rattling away, busy, minding their own business, doing some stuff. And it could well look like this. Lots of people beavering away, finish my bit of design, I'll move into coding, I'll finish my analysing, I'll get something else out of the backlog. Lots of things happened, yeah? So what happened actually? Lots of activities, but I've still got a whole chunk of stuff left in work in progress. I've got 14 things, we actually delivered 2. And if any of you are drawing burn up or burn down charts, they'd have looked a bit sad and sorry. Lots of work going on, but not a lot actually happened. And these are the same chart, just drawn differently. I think there's some people don't like the idea of burning down. They'd rather burn up and build value, but it's trying to say the same thing. So that's not great, but there is a simple, fairly simple, straightforward, let's call it straightforward, mechanic that we can apply called WIP limits that will change the behaviour of this team. Anyone here experienced WIP limits before? Expecting a few, quite a lot of nods. Good, that's okay, and some people who haven't, and that's equally okay. So how do they work? Now, it's a number. We specify the number of objects that a column on this board, or indeed the whole board, as you can see, it's set for the whole area, can hold. So I could have a quick factor at this and come up with something like this. So analysing should only hold one thing, design 2, coding 2, testing 2, integration 2. Why not? And if you apply these and you've got more objects as I have, that's fine. You don't try and back things up. You just let the board flush down to the right level. So if I do have these things, what happens? Well, actually, things move slightly differently. I'm in a situation where, as you've just seen there, some things moved. Actually, all the columns are holding quite a lot of stuff. They're all on or breaking their WIP limit. Now, when I click there, a couple of things nudged over, but I'm now in a position, really, where my board is absolutely stuck in the WIP space. So if I click again, the only way for me to get things moving is to actually start getting things moving into done, and then it makes space for things to pull across. This is a pull system. I'll click it again and you'll see actually things are being pulled across the board, but I have to make space for the things to come across, and this means ultimately that I have to get things finished. I'll just click once more. There you go, you'll see the pull. And ultimately also, now I've probably got a team thinking about getting things done because actually, you know, they're focused more across the whole board. By the time you get to the end of an iteration, they might say, well, you know what, we're never going to get these things at the front finished, so let's just get maybe a couple more. Let's mob around the last 2 things and push them over the line. Wow. Okay, so same amount of work done in both those flows, actually. You didn't need to count all the boxes moving, just trust me on that. So delivered 6, so 3 times as many, remaining WIP 8, half. All I did was add some numbers to columns. Yeah, sounds all right, doesn't it? Right, so that sounds great, but then some teams go, okay, fine, when I'm presenting with this, so if you want to lower WIP, that's fine. all we'll do is we'll just make our stories a bit bigger. That's okay, isn't it? Then we'll have much less of them. Or fewer, apologies, my grammar. Let's have fewer stories by making them bigger. Yeah, don't do that. Please don't do that. I've seen people do that. It looks really easy. Let's have 8 big stories instead of 16 small ones. No, because that runs us into batch size. So, batch, there's a word. What's a batch? Good question, actually, and I've put some sort of examples up here. Items in a box, stories in a feature, parcels on a pallet. The number of tests in a regression pack is kind of up to us, what a batch is in our own context. But of course, this comes from a context of manufacturing. And here's a description from manufacturing. So let's think about the roots of what it was trying to achieve. So it's a method whereby a group of identical products, and you should never read your slides, should you, but I'm doing it to you. Look, reading my slides. A group of identical products produced simultaneously. It's up to the manufacturer to decide how big the batch will be. Sometimes it's actually up to the customer to bring what they order, and how often these batches will be made. And it will go through the separate steps of the manufacturing process as one batch. In manufacturing, if you set up tooling or something like that, you can't start doing other things anyway because, hey, you've kind of configured your production line to deal with that one batch. So I had a stab at writing what that might mean in software delivery terms because, hey, I imagine most folks in the room are interested in software delivery. So, group of related requirements delivered simultaneously, considered together as one unit of work. It's up to the organisation to design how big that batch will be and how often they'll be made. And each goes through the separate stages of the software development process together, meaning that another batch, and I've written should not, instead of won't, beginner stage of the previous one is still in the cycle. Because ultimately people always try and shove things in, can you start this as well? So ideally should not. Now the thing about batches is, I mentioned the learning cycle earlier, plan, do, check, adjust, plan, do, study, act, all the different variants of it, OODA, whatever you choose. But ultimately, we don't execute through the learning cycle until we have delivered a batch. That is our smallest unit of learning measure, if you like, is the actual batch. Because until I've delivered the thing, I can't learn how well I delivered it. And I've got some lists here of batches you might recognise. A story itself is a batch, single story. It's a batch of acceptance criteria. A feature could be a batch of stories. A sprint actually is a batch in itself. You've got a collection of stories in there. And I've written a project on here. And for those folks who've read books about moving from project to product and things like that, apologies, I'm going to gently poke at project a little bit. A project is a very large batch of requirements. You've probably got a 30 or 40 page requirements document at the start, full of lots and lots and lots of user needs. It is one big batch that you are potentially going to try and execute. And even if organisations say, hey, we're Agile, what we're going to do is we're going to take that apart in the middle, somehow use something that looks like Scrum, but then we're still going to put it back together again afterwards, doing water Scrum fall. Actually, it's still a great big batch. We don't learn about the project delivery until we get to the end. So it's really important to think about the learning loop, as Eric Ries would call it from the Lean Startup. Now, another thing about batches is batch variability. If you work with large batches, such as projects, but anyway, just think about it on a scale. It doesn't have to be projects. It can just be large user stories, if you like, or features. There is a challenge in cycle time. You can see cycle time on the chart here. I get very high variability in cycle time, depending on utilisation. So now if you think about utilisation, we're all busy folks, aren't we? I imagine most of you are working in busy departments, busy IT departments, yeah, busy, high utilisation environments. Anyone working in a low utilisation environment? No, yeah, it doesn't tend to happen. Okay, so look what happens to large batch sizes in a high utilisation environment. The variability skyrockets, really shoots up as you get over about 50%. If you look at the medium and small batches, that's really not impacted until you get a lot further up, lots further up. So anyone here working in a high utilisation environment, IT function that's really busy and trying to deliver lots of projects at once, recognising they're a large batch. I can see some nods in the room. And how predictable is the delivery of those projects? Do you have high confidence in the dates that are given for the delivery of those projects? No, usually not. Actually, it's almost impossible to forecast, actually. So I put a note on this one here, really, just to make the point, I suppose. You know, if you are in a high utilisation environment, you're under pressure, got to deliver lots of projects, you're working in a fairly traditional manner, these are large single batch endeavours. There's going to be massive variation. There is high WIP, you've got so much on the go and projects will run late. When sometimes people say to me, oh, you know, we've got so many, we just can't deliver anymore. I ask the question, well, how many things are you trying to deliver at once? I say, well, what do you mean? Well, how many projects have you got on the go? I did some work with a general insurance company, a modest-sized insurance company, a couple of years ago, probably 3 now, considering COVID. There were 60 people in the delivery function, and they couldn't ship anything. I said, well, how many projects have you got on the go? 72, they said. There's the problem. Because they were doing utilisation-based planning, actually. As soon as anyone came free, if an analyst, oh, I've just finished writing that requirements document, somebody went, oh, great, can you start writing the requirements document for this one then? They wouldn't let people rest. They wouldn't let there be any gap in the system. High utilisation just kept getting things started all the time. And the title of the talk, stop, start, and start finishing. It was preventing them getting anything finished. Now, it's all well saying, oh, well, big batches are bad, small batches are great, which is true, but actually there are economies here. You can't just say, well, the optimal batch size is microscopic. It is one line of code, one unit of measure. There is some thinking behind this, and this comes from Don Reinertson's book. I mentioned Don earlier, Principles of Product Development Flow. And he makes the point that there's a couple of costs that have an interplay that we need to think about when we think about batch size. One is called holding costs. That's the linear line running left to right. This is almost the cost of holding your features back from market, the cost of holding inventory of code. And then I've got transaction costs, which is the dividing curve running the other way. And then I have a stacked addition of the two that gives me the orange line. So effectively, where the stacked addition of those two costs is lowest is my optimal batch size. Now, you have to look at your own context to decide what your own context looks like, to decide what your optimal batch size would be. But I'll give you some examples of transaction cost and what happens in that area. If you think about transaction, this is moving something through a system. So for argument's sake, taking some code from staging to production. Or maybe just doing some testing, taking something from untested to tested. So if moving from staging to production, if I turn up to my ops folks with 10 line of code change and say, oh, can you just pop this in production? And they say, phew, well, you do realise I've got to make a local copy of the production database first, and then having done that, I've got to take your line of code and I've got to put it over there, and then I've got to put it on a machine over there and do a build on it, and then having done that, I need to take it over there and put it through this magic widget thing. Then I need to open some ports on a firewall. Having done that, then I get to push it in production, having made a build over there. You get the picture. It's a big manual process. There is a high transaction cost. There's a lot going on there. That person has to do a lot of work. It sounds like hours or days worth of work to put 10 lines of code. So I'm never going to go there with 10 lines of code. Actually, he'll say, can you come back when you've got 1,000 or 2,000? And then it's worth doing. But just say I had an entirely automated pipeline and I could move something from staging to production by the click of a button. It's all scripted, all happened, it's all nice and safe. I turn up and say, can you pop these 10 lines into production? And you go, yeah, I'll just click the button before I go to lunch. Click. Yep, it's done. Low transaction cost. Same exists in testing, manual testing versus automated testing. Reduction of transaction cost is very much, you can achieve this through things like automation. If you have highly manual processes, you have high transaction costs, which will tend you to a larger optimal batch size because it all seems not worth it. But actually, if you can reduce your transaction cost, you will find your optimal batch size will just gently move to the left. So, very much worth thinking about. So don't just say, oh, well, we have to work at a micro scale, but work out where you are and then work out how you can reduce it. And you can. Say, oh, you can make a business case for automation off this slide if you wish to. So a couple of obvious statements. So large batch, it's got a lot of work in it. It has a slower and less predictable cycle time. And we talked at the start, cycle time, that's getting it done. Small batches, well, they require a small amount of work. Fine, yeah, good. They're much more predictable, really a lot more predictable, and have obviously a much faster cycle time. So hopefully this is hooked up enough to the internet that I can show you a little video, tiny video. I'm just going to show you a quick simulation of a process. It's going to run in 3 batch sizes. At the bottom, I'm going to have a batch size of 1. In the middle, I'll have a batch size of 5. And at the top, I'll have a batch size of 10. The work's all going to move at the same kind of rate per object, but let's hopefully see what happens here. restful. Yeah, there you go. So all that changed there was batch size, but actually the time to get 10 things delivered was double. Well, it was 21 seconds to 40. Nothing else changed. So by working in small batch sizes, we can very much change our rate of delivery. Often large batches are a main problem. So let's go back to here, or rather actually let's go back to here. Something else we need to think about. So we've already said that our work in progress is this stuff here in the middle. Okay, lovely, maybe, or is it actually? Because I'm going to have queues, and I'm afraid this projector doesn't show this very well, but it says ready on these grey columns that I've just put inside the dotted line. Apologies, we can't see it very well. But actually, these are ready states. And actually, whilst you might say, well, the WIP's 8, it isn't actually. The WIP's only 4. I've got 4 things that are basically waiting for the next process. That's interesting. They're inside a queue. And interestingly, I talked about lead time and cycle time. The difference between lead time and cycle time is actually queues. The work's sat somewhere, not being worked on, but it's in a queue somewhere. So when we start talking about queues, it's worth thinking about Little's Law. Here it is. Looks a bit complex, but it isn't. Little's Law says, okay, your average wait time in a queue is the average queue length divided by the average processing time. So if I'm in a queue of 10 people to buy a coffee, and it's taking 2 minutes to serve each person, I'm going to wait 20 minutes for my coffee. And in a rather troublesome manner, I tend to work that out in my head when I walk into a Costa or a Starbucks. I look at the length of the queue and think, well, it's probably 90 seconds a person. Have I got time? And sometimes don't wait. So if we can decrease our queues, actually, we can decrease our, effectively our process. We can improve our process efficiency. So how do we do that? Well, shorten our queues. That's great. Make the queues shorter themselves. You can do that just by saying, well, we're going to put less work in the system, actually. And indeed, if you can improve your processing time, again, you can reduce your queues. Now, how do you improve processing time? Look at your process, look at the skills of the people involved, maybe move some people to work, do what you need to, maybe combine columns, kind of work that system that you've already got described and see what you can find out. Now, one of the things about capturing your queue states here is suddenly we can start looking at process efficiency inside our overall system. Because whilst I've got that lead time I described, lead time, cycle time gives me my process efficiency. But if I can get some data here, because I've got effectively a queue and the processing time, I can see my process efficiency by step. And this will tell me some interesting things really about where the efficiencies and the inefficiencies in my process exist. I will just mention one thing for the Kanban folks in the room here. Any Kanban people here? Okay, good, right, okay, so I'll just mention a buffer for the bottleneck in the system. All good, right, so we'll mention this. If you have a particular part of your system, which is your bottleneck, and if anyone here has read Goldratt's book, The Goal, you will have read about the theory of constraints. There's another nice little book called The Bottleneck Rules that speaks about this. But actually, if you've got one critical bottleneck, do make sure it doesn't run out of work. So you might want a buffer state in there. So most, I guess, important takeaway from that bit is get data. All the things I've been talking about, those measures, are measures you could take. Your tool set will let you take those measures. I don't know what your tool set is. Don't just do what Jira tells you, by the way. If anyone takes Jira out of the wrappers and goes, oh, we'll follow that workflow, it might not match what you do. So do model your process in your tool set. Do potentially put in those queue states, and then do get the data. If you can get timestamps for all the work flowing through your system, suddenly you can do lots with that data. Now, some of the things you can do, you might be familiar with these. Cumulative flow diagrams. Anyone seen these? Yeah, a few nods. Don't worry if you haven't. These are quite cunning, because all I'm doing is charting out a cumulative stack of the work in the different work states at any particular time. But what they give me, oh, I'm armed and dangerous, got a laser pointer, I can measure lead time and I can measure cycle time on these charts. And equally, I'll get quite interested in what we call the arrival angle and the departure angle. Because actually, if the arrival angle is steeper than the departure angle, so that's this bit here, average, versus this bit here, I know my WIP is just going to be increasing all the time. Top one actually comes out of Jira, I think. I'm not sure where this second one comes from. Really useful tool. I would say there are other things you can do which are probably a little bit more, I wouldn't say interesting, detail. Cycle time scatter plots. Anyone doing these? Some people. Excellent. Good. Right. You can take this talk next time. All good. So, these are interesting. What we do is, when we deliver work, on the date we deliver it, we put on a chart how long it took to deliver it. It's up this side here, number of days to deliver. So what this is showing me here is on these days I'm delivering this work. That took no days. That must have been tiny. But here these things took on it sort of 10 days, 9 days, 7, 2 or 3 days. I'm literally dotting on here how long it took to deliver that piece of work. And what have we got up here? 40 days. I wonder why. And the orange lines, you can start to put your, oh, the words left me. Someone else help me draw cycle time scatter plots. Percentiles, thank you very much. Percentiles. You can put your percentile lines in here to give you, start to give you predictability. Exciting. And equally, if you get outliers, you can start to wonder why, because actually that's quite interesting. So that's something else you can do. I can ask the question again now. Anyone doing Monte Carlo analysis and simulation? Yes, one at the front and then nearly halfway back. Good, right. This is really interesting. It's a little bit nerdy, but really interesting when you get it running. There are Excel documents and tools out there that will do this for you. Basically, you churn in all of your data. It runs a whole bunch of what-if scenarios and modelling on your data set and brings you out a set of charts that give you percentile probability of achieving things. So at the top, okay, how many days would it take me to deliver 10 stories? And this is saying, well, our median on average, 13 days. Depending on how much probability you would like on that, if you want 95% guarantee, we're going to be here, sorry, 23. If you want 99% out here, actually, you know, these things can run out. And equally, you can do it the other way around. Okay, how many stories can I complete in a period of, say, 14 days? Or you might model this on a sprint. This is really good for sprint planning. Well, actually, our median is we do 11. Actually, there's a 25% chance we could do 14, 85% chance we can do 7. So, again, really nice things you can start to get from data if you start capturing data. The trick is to capture the data in the first place. I would say a lot of teams and organisations are really quite poor at gathering data. Okay, so that's teamy stuff, but it's not just about the team, is it? There's a bigger picture going on, actually. There's one of those, but in fact there's probably more than one of those. There's probably tons of those, isn't there? Anyone here working in a one-team company? Nope, okay. Right. Some are, it's all right, it's okay, startups. And of course, surrounding them, there's somewhere upstream, a long way upstream, there'll be some big roadmap and there'll be a whole bunch of things going on, business cases being written, funding being applied for, backlogs with projects in them, requirements, product management getting involved, architecture, lots and lots of things. And of course, inside those things is lots and lots and lots of work. Yeah, actually, and of course, out the far end, release management validation. Probably got some roadmaps down here as well, all good fun. Because roadmaps tend to be trying to manage queues, ironically. This is all work in progress. Whew. Somehow organisations don't see it like this, but this is actually the case. As soon as someone approves a business case and say, yeah, that's something we want to do, or in fact even writes it, approves the writing of a business case, it becomes work. Now, this is where the conversations around lead and cycle time always get interesting, because I talk about lead time as starting way out here somewhere in this space, whereas most people like to talk about it starting somewhere over here. But actually, not really. Because sometimes something can spend 4 or 5 months before it even gets towards engineering. Now, here's something. This is a portfolio Kanban, which helps us view the overall picture. And this has come from the SAFE framework. Right at the top of an enterprise, you can apply portfolio Kanban. I would say SAFE didn't invent portfolio Kanban, that's for sure, but I just happened to use their screen here because it's got some really nice stuff on it. Actually, you can start to think about the flow of work into the system, which is the delivery engine, if you like, and what the SAFE folks have done here. Oh, look, there's those WIP limits. You can apply WIP limits at the top of your organisation, and there's that word pull. You know, I said there was a pull system we saw earlier. Why not apply a pull system right at the top of your organisation so that there is not so much WIP inside the organisation? Instead of just starting projects constantly because someone thinks that's a way to get them delivered quicker, why not actually pull them when there is room for them to be delivered? Radical stuff. Okay, something else people get a little bit confused by. Well, maybe not confused, but distracted. Throughput. Hey, we got really good throughput. Yeah, don't worry about all that stuff. We've got great throughput. We're delivering 3 features a week. That's great. Brilliant. Okay. Well, What if I was only delivering two features a week? Well, when I want a new one at the top, yeah, there could be a huge queue going backwards and another queue going on here. And actually, if I'm doing 2 features a week, I might have so much of a queue. So 18-week wait to the top for a new feature, 6-week wait to the bottom. My throughput's only 2, but there my throughput's 3. So don't get baffled by throughput. Don't think throughput's great. Do not get too excited about throughput. Because what happens is when you've got good throughput as well, people go, brilliant, let's start some more projects off then. And look, the world just got even worse. Damn it. Okay, so don't do that. Because if you're going to start more things, all you actually do is means you wait even longer for all the things that you're currently doing and those things that you've just asked for. So key takeaway for any leaders, managers in the room, please do not try and keep everyone busy. That's one of the worst things that you can do, actually. Utilisation-based planning. You saw the batch size charts, all those good things. Oh, an analyst has just finished something. Let's get them to start something else. This is all painful stuff that basically stops the machine from moving. Don't do that. Okay, so if we're in a world where we say, okay, well, we're not going to do everything then, and of course everything's important, isn't it? We have to do everything, but we don't. So if we say, well, okay, we're not doing that, well, what are we going to work on? And this is something that organisations really struggle with. So what do we do? Because there's lots of different dimensions of what we're going to worry about. Actually, how are we going to decide? And the answer is, you want to work on the things that give you the best economic outcome. And for that, you need an economic model. It's easy to say economic outcome, but as an organisation in your own context, you need to think about what that means. Something which has been around for a long time, I would say, I remember talking about this next slide probably, I'm going to say 15, 20 years ago, and it predates that for sure. Cost of delay. Anyone heard of cost of delay? Yeah, lots of nods. Anyone using cost of delay? Some, but a lot less nods. Yeah, a lot less. Cost of delay is interesting. This is a quote from Don Reinson here, actually. So it's a way of communicating the impact of time on the outcomes we hope to achieve, actually. Tricky stuff, actually. And the thing, I mean, Don says here that cost of delay is the golden key that unlocks many doors. Kind of, yes it is. But does anyone remember this? Cost of delay divided by duration. I used to talk about this years ago, CD3. Yeah, anyone? A few, a couple of waves, yeah, maybe. Actually, this really comes alive when you start thinking about the duration, how long it takes to get something done. This actually is what unlocks the doors for me. Actually, as it says, it maximises the total value delivered, and that's based on cost of delay, in any given time period by a fixed development capacity. Whew. Now, I'll tell you the mechanics behind this, because it sounds quite tricky, but actually, there's a little logic behind it, which kind of, I find, works quite well. And I've borrowed this from a safe training course, because I think it explains quite neatly how cost of delay tries to work. Just assume I have got a farm machinery shop, and I sell farm machinery, and I've got 3 things I can sell. I've got customers, they'll buy stuff, they're out there. Each thing, as you can, I'll use my laser pointer here, each thing is going to sell for the same amount of money. Okay, same amount of money. But I've got to spend a day preparing this one, 3 days preparing this for sale, and I've got to spend 10 days preparing that for sale. Which one should I work on first?
How much do they cost?
A. I heard A. A is correct. It's not a trick question. And it's not all of them. I have a fixed resource capacity. Work on A. So that's one lever inside it. The other lever is this. Let's imagine it the other way around. Okay. Everything is going to take 3 days to get ready for sale, but this one is worth a lot of money. This is going to sell for a moderate amount of money. This is going to sell for not a lot. Actually, which should I work on first? A. A again. Because if I work on C first, yeah, I'm going to spend 3 days but not get much economic return, whereas if I work on that one for 3 days, I get a lot. Those are the 2 levers that exist in the background behind cost of delay, indeed cost of delay divided by duration. I'm just going to jump back to the safe portfolio because it has something on it that I will also mention, which is here, something called WSGIF. There's a catchy thing to say. WSGIF, weighted shortest job first. And for any of you folks in the room have looked at SAFE, this actually is simply cost of delay divided by duration, actually. But the SAFE folks have said, you know what, we recognise there are components in cost of delay. This is quite useful. It's not just about what it's worth to the business. It's not about how important, just how time critical it is. It's not just about what else will it do for the organisation. It's all of those. And actually, if we understand the concept of job size, that'll work quite nicely in proxying duration. Because if you don't know who's going to implement something, actually just its bounding size makes a reasonably good amount of sense. So I'm going to give you a quick walkthrough of how this might work. Now, in your context, you could round up 20 things, 15 things, a dozen things that you might want to do. They might be inside a backlog. They're things you haven't started yet. In my simple example here, I've looked at 4 features that you might wish to build into a car, just for fun. So I've got 360-degree video recording in the event of an accident. Somehow, mystically, cameras will turn on and record what happened. I've got automatic parallel park, that thing that does the steering and measures the gaps and does that. Looks incredible. I'd love to have that. Cruise control and all-round heated seats. Sounds good. Anyone got a car with all of these? No, me neither. Okay, never mind. Okay, now, this little chart charts out the different elements that you saw in the previous calculation. Here's the first one, user business value. Yeah, what's it relatively worth to our customers or to our business? And there's the word relative, because we don't need to work in absolute terms. Actually, if I can find the thing that gives me the least and score it a 1, I can use the Fibonacci scale, just like we use for user stories, to say, well, relatively, how do the rest of them look? And I might say, you know what, heated seats, here they are, actually, that's going to give me a modest amount of value, but, you know, it's less than the others. And relatively speaking, I think this could give me a bit more. I don't plan on having accidents, so, you know, actually, you know, it's probably something I'd like to not ever use. Cruise control, yeah, I like the look of cruise control, but actually that auto parallel park will give me a lot of value because I'm pretty rubbish at parking. So, then I can look at the next column. Okay, time criticality. What's happening to business value over time? How does it decay? Will our customers wait? Will the market move? Will things happen? And I can apply the same kind of logic. Say, well, which is the least time critical? And I might say, well, actually, I'm not planning on having any accidents. So for me, that feels the least time critical. And heated seats, well, it's not winter yet. I don't need that yet. And cruise control, yeah, it would be nice. But actually, I'm really interested in this auto parallel park. I'd like that soonest because I've got arthritis in my wherever and actually parking in my neck turning, all that kind of thing. So that's how that one works. And let's look at the third one. So risk reduction and opportunity enablement value. What actually will this thing do in reducing risk or enabling future opportunities? And I could say here, well, you know what, actually, heated seats are heated seats. That's what they do. They don't enable me anything else particularly. That makes good sense. But actually some other things here. And in fact, parallel park. Well, it parks, that's lovely. Good, but it does that. But, you know, cruise control, that's interesting. And 360 video accident recording, they might enable other things. Cruise control, for example, if anyone's got one of those cars that stays in lane and kind of sort of self-drives a bit, actually, you could be saying, well, we might use some of that feature for that. Equally, 360 video accident recording, we could say, well, that's really quite handy for a bunch of other reasons as well. You know, maybe I could use that for, well, part of the lane camera work, but also part of, reversing cameras, those kind of things. So lots of opportunity there that I might have as a result of implementing that feature. So then I can add them all up, bit of maths, which gives me that thing called cost of delay. And then this is where you get your architects or tech leads involved, all the clever people, to have a stab at, well, how hard are these things? And they're going to say, in my imaginary scenario here, actually cruise control is really straightforward. All we're going to do is just peg the speed the car's doing electronically and it's just going to maintain that speed. Great. Sounds easy. Heat seats, that's pretty straightforward. Do need to do some harness wiring inside the car. It's a bit more complicated, but actually that's not too bad. Video camera recording, yeah, a bit more fiddly, quite a bit more fiddly, but certainly not as difficult as auto parallel park, which has to interact not only with the electronics of the car, but also the physicality of the steering. So your tech folks could have a stab at that, and that will then, by the power of maths, dividing cost of delay by duration or by job size, the proxy for it at the moment, give you a set of numbers. And that set of numbers should be the order in which you deliver those things that will give you the best economic outcome. And sometimes people look at this and go, oh, that's a bit surprising. What you tend to find is there's usually some little things that add a sort of small, modest piece of value actually will come to the front. Ironically, through things like risk reduction and opportunity enablement value, if anyone's ever struggled to get a replatforming or a big tech implementation project through a big enabler program, they score massively in this space here. So actually, this very much helps balance out the world. So this is a way of thinking about the order of work, which works as a really good sorting hat to help you in the conversation about let's not do everything, let's work out the order that we should do things. And you can apply this pretty much at all levels inside a backlog. I would say actually at the team level, maybe less so. That feels a bit too much. But actually, certainly at the portfolio level and a program level, you can apply this very much to make sure you don't get too much stuff hitting the team level. Because actually, when we talk about WIP, we're usually talking about these folks having been totally overloaded by the 2 layers above. Tell me I'm wrong. Okay. Right, so let's wrap up quickly, because we are down to the minutes on time. Hey, did you see what I did there? Anyone? Yeah, this doesn't happen by accident, you know. Okay. Photograph this slide. There you go. Make your life easy. Okay, work in progress is the biggest problem you have. You probably think it's something else, but actually it is the biggest problem you have. Map your processes out. Please actually understand the process you're following. Do it at team level, department level, enterprise level. Visualize all of your work. Actually see the full work in progress. Apply systems thinking to those progresses. Lean them out. Look at the queues. Look at the bottlenecks. Work them through. Use WIP limits to drive that WIP down. And don't just do it at team level. Do it elsewhere in the enterprise. Make sure your batch sizes are smaller. Look at how you can reduce transaction costs using things like automation. Please stop trying to keep everyone busy. That is a short journey to a whole heap of pain. You need space inside your system to actually learn how to improve it. So let people have that space. And last but not least at the bottom, create a robust economic framework that means you can consistently prioritize work. Try C3, try wait your shortest job first, try anything else you like, but actually just try and sort out all the work so you don't try and do all the work at once. Thank you. Right, quick before you clap. We'll just mention 3 books worth reading. There are many, many books out there. There is Principles of Product Development Flow by Don Reinertsen, full of all the maths. There is a book from Deming, Out of the Crisis, full of some really nice management thinking. And here is a pretty new book, Applying Scrum with Kanban, by a chap called Andy Hiles. If you are a Scrum team thinking about any of the sort of nuts and boltsy, numbery things that relate to Kanban and applying them to your Scrum team, please have a look at that book. And in almost like a message from my sponsors, if you like, I will say everything that I've talked about inside this talk is inside the SAFE framework, inside their core values and principles. So if you're interested, have a look at that as well. Thank you very much.